Welcome to Brain Vision.
So we're going to be evaluating the surface integral. What we have here are two integrals. And we know that this is going to be x, y, z, s. We know that how this is going to look for the surface integral is it will be f of r of u and v times the cross product of ru, rv, dA. So based on all this, we first want to find x of u and v, so create this parametric equation. We know that that's u cosine v. So based on that, we want to take the partial derivative of x with respect to u. We get cosine v, and then we want to take the partial derivative of x with respect to v, and we get a negative u sine v. We do the same process for the partial derivatives of y with respect to u and v. We get sine v and u cosine v respectively. And then we want to do the same thing with z, u, and v. So we'll end up getting 1 and 0 for the partial derivatives. So based on that, we see that ru is going to be equal to, it's going to be a vector. It'll be cosine v, sine v, 1. And then rv is going to be another vector, which will be a negative u sine v, u cosine v, and 0. And then based on that, we can take the cross product of those, and we end up getting, we do r u cross, we'll just do an x to make it look like that, r v. What we'll end up getting as a result is a negative u cosine v, negative u sine v. Go. So now that we have that, we want to take the magnitude of that, and we'll end up getting u square root of 2. Just by following that process. So now we have most everything that we want. The only difference now is we need f of r u v. So based on that, since f is x, y, z, we'll just plug in x, y, and z. So what we'll end up getting as a result is going to be u cosine v times u sine v times u. So this will be equal to u cubed cosine v sine v. And this comes from what we solved for earlier. Then based on all this, we can now take our second integral, or our double integral. We'll have an integral from 0 to pi over 2. Of the integral from 0 to 1 of u cubed cosine v sine v times the square root of 2u. But we can pull out that square root of 2. So what we'll end up getting as a result will be the square root of 2 and then the square root of 2u. And this will be du dv. Then we can separate these. We'll put the cosine v sine v right in here. dB, and we'll remove it from right here. And then on top of that, we can now evaluate this. This will be, since we took out the square root of 2, this will be u to the 4th. Then we know that when we evaluate this right here, this will become 1/2. So multiply this by 1/2. And then this right here will become 1/5. Multiply 1/5 here. And we end up getting this right here, 0.1414. So that is the same thing as the square root of 2 over 10. And that would be our final answer for this surface integral.